All right, practice. Okay, try it. If you're stuck, let me know. If you want me to check, let me know.
I'm stuck.
Already? Okay, I'll check. All right, the answer is negative 273. Okay, so be careful of the little details, like a lot of you just, added wrong, or you forgot a negative, or you copied over wrong. It would just kind of be detrimental. So please be careful. All right, now I am going to show you how to do it on your calculator. Yes, you can do this on the calculator. All right, so take out your calculator.
But are we gonna use it?
Yeah, you have to use it for the test.
Yeah?
Yes, or else it will take you forever to solve if you don't use the calculator. So let's use the calculator. You could, yes, you could, yes. All right, you are gonna, go to matrix, but we are going to type in this matrix, this big matrix. What size is this matrix?
4 times 3.
4 by 3, okay? Oh, no. 3 by 4. 3 by 4. 3 rows, 4 columns, okay? Not a 3 by 3. We are looking at a 3 by 4. Okay, so type in all your numbers. So go to edit and then type all of them in. Okay, once you enter the 3 by 4, you're going to ask your calculator to calculate the row echelon form, which means you're going to go to matrix again, and then this time you're going to look for the math button, and then if you scroll pretty much all the way down, you're going to see one that says REF. That is the row echelon form, right? Okay, so choose that one, and then you're going to choose your matrix. Okay, that's going to give you the row echelon form. Whatever the calculator's algorithm decides what is the row echelon form. Mine says 1, 0.5, negative 0.5. Sometimes you have to scroll to the right to see all the numbers. 0. And then 0, 1, negative 1.4, 2.8. And then 0, 0, 1, 3. So my calculator tells me this, and then what I need to do is change that into system of equation so I can figure out the answer. Okay, so this is row echelon form. Tomorrow I'm going to teach you even easier way, but tonight just get stuck with the hard way, for now at least. Okay, so this is what you do, row echelon form. It's going to give you that answer. Make sure you scroll all the way to the right to see all of the numbers in that matrix, and then you still have to go back and solve each one.
So it doesn't show.
It doesn't show all of the numbers?
Yeah.
You have to scroll all the way to the right.
Yeah, I mean X, Y,
What?
I mean it has different numbers.
From mine? Is that what you're saying?
From my.
Oh, right. Okay, so your numbers actually may not be exactly the same as mine. And these don't look exactly like your row echelon form. That's okay, because you just needed to solve X, Y, Z. It will still give you the same numbers. Yeah. Even if the row echelon form does not have exactly all the same constants. That's okay. All right, you guys are good? Yeah, question? Okay, you need help. All right, anyone have general questions for this lesson? No, everyone's good? Okay. So yesterday, we learned the row echelon form. Yesterday, we learned the row echelon form, which says, if you want to solve an equation, system of equation, if you can get it into a triangular form, it will help you solve it faster. I'm going to teach you another thing today. It's even faster. It's called the reduced row echelon form, RREF, with another R. This one looks like this. It is also a triangle, but its triangle is a little different. It goes 1, 0, 0, 0, 1, 0, 0, 0, 1. So the identity. matrix. On the side, it's A, B, C. So much easier this way because X is just A, Y is just B, and Z is just C. We're on page 8. All right, so we are going to get our matrix to look like that. Let's go to the next page, which is page 9, and we're going to practice. Let's practice this one. So you are going to first change the the system of equation into matrix form. So change it to matrix form, and we're going to do it together. We're going to get it to look like identity matrix by doing this. This needs to be 1. This needs to be 0, 0. This needs to be 1. This is 0. This is 0. This needs to be 1. This is 0. This is 0. Okay, we're going to do it in that order. Get the 1, get the 0. Daniel, can you get it over? So first get the 1, fix the zeros. Next, go to the next column.
It's going to take the rest of the period.
Okay, yeah. Take column 2, fix the 1, get the other zeros. Go to the third column, get the 1, and then fix the others to get it to be 0. Okay? Okay, well, we'll do it, and then you'll see it. All right. Top left. I need this to be a 1. It is already a 1. We are good. Fix the next one. 2. I need this to be a 0. How do I do that?
2 times row 1.
Negative 2. Add to row 2 and then?
Replace row 2.
Yeah, substitute or replace row 2. Okay, good. So we're going to multiply row 1 by negative 2. Add to row 2. Replace row 2. Okay, so like what you did last night. Negative 2, 4, negative 2, negative 16, 2, 1, negative 3, negative 9. Add them together. 0, 5, negative 5, negative 25. Replace row 2. Okay. Next, I need this negative 3 to be a 0. What should I do? Multiply row 1 by 3. Add to row 3. Replace row 3. Okay, so go ahead and do that one. All right, everyone's good? Yes. All right, column 1 is fixed. We are good. Next, we're going to go to the second column. We're going to fix that 1 first. Divide everything by 5. Yeah, that's the fastest way. Divide everything by 5. That will automatically become a 1. Next, let's fix this -2. What should I do?
Multiply row 2 by 2 and then add it to 1 and then replace 1.
Good. Multiply row 2 by 2, add to row 1, replace row 1. Good? Everyone got the same? All right, I'm going to have you fix -5. Make that a 0. So fix that -5 and make that into a 0. The answer is 2, -1, 4. Okay, so this method is actually much better because once you solve it, you will get exactly the answer. You don't have to do, substitution back. So I'm going to show you how to do this on the calculator. You do need it because you need it to solve like next section. It's all, if you don't use this, you're going to have like 4 or 5 variables you cannot solve. You have to use the calculator. So you are going to type this matrix in the calculator. This time you're going to choose RREF instead of REF. Okay, so type this in the calculator. Okay, so everybody knows how to do RREF on the calculator. Okay, you have to do that because it will get really crazy later if you don't. Let's try this one with just the calculator. Okay. This one has a very interesting result, so it's much better if we just look at the calculator answer. Go ahead and figure out what the answer is of this matrix. If you do RREF, you should get 1, 0, 3, 5, 0, 1, -2, -2, 0, 0, 0, 0. Okay, what does this answer mean? Oh, no solution. That is not correct. There's a difference between no solution and infinitely many, right? No solution means like that. 0 equals number. This just means that row is just 0. Meaning we just have 2 equations.
We don't have Z.
We don't, well, actually, we don't have enough of information to figure out anything. Okay, so if we rewrite this, this becomes x plus 3z equals 5. The second one becomes y minus 2z equals -2. That's it. Remember, to solve three variables, you need 3 equations. If there are only 2 equations, you cannot solve. Okay, so what do we do?
We do it again.
No, do it again, it's just going to give you the same thing. Okay, so basically it's infinitely many solution, which means you can write it as any answer you want as long as you keep the relationship. Meaning, if I want to write in terms of z, then x is 5 minus 3z, y is minus 2 plus 2z, and then z is z. So this is 5 minus 3z, -2 plus 2z, and then z. Basically, there is no definite solution. It's infinitely many, so as z changes, x and y will change. but there's a relationship between x, y, and z. Not really. I mean, you can graph the relationship, but as you change z, everything's going to change. All right, last thing we're going to do today is we are going to revisit inverse matrix. This one should be pretty easy because you did learn this last year, and I heard most people feel it's the easier way. We're going to solve this, but we're going to use inverse matrix. All right, recall. It looks like this. We have the coefficient matrix, the variable matrix, and the constant matrix. You guys remember this from last year? All right, so 3x minus 2y equals 0. What's the constant of the xy part? 3 and negative 2. Okay, the variable matrix is just going to be xy. And then the constant is going to be 0. And then we take the second equation. Minus x plus y equals 5. Negative 1, 1, 5. So basically, we take the constant coefficients, put in one matrix. Variable, up and down. And then constant is by itself. All right, we're going to solve this. We're going to solve for x and y. Usually, you just divide, right? Divide the coefficient L, you get xy. But we cannot divide in matrix world. What do we have to do? Multiply by, not inverse. We're going to multiply by inverse. To get rid of something, we have to multiply by inverse. Remember, inverse times itself becomes
0.
I. Yeah, the identity matrix. Whatever we do to the left-hand side, we have to do to the right-hand side. But in matrix world, order matters. So when I multiply the inverse matrix on this side, which side of the constant matrix should I multiply? On the left or on the right?
Left.
On the left. Okay, please be careful. On the left. So xy is equal to 3, negative 2, negative 1, 1, inverse times 0, 5. All right, we're going to solve this by hand, and we're going to solve it using the calculator. All right, how do you find the inverse of a 2 by 2? The ribbon. So 1 over determinant. What is the determinant? The ribbon. So 3 times 1 minus negative 1 times negative 2. 1. And then switch these two. So switch 3 and 1. Make the other 2 negative. And then multiply by 0, 5. Are you guys still good? You guys, like, some people are like squinting, so I'm hoping if you have questions, just ask. All right, well, the determinant is just 1, so I'm going to ignore it. Now I'm going to multiply those 2 matrices together. 1, 2, 1, 3 times 0, 5. No. 1 times 0 is 0. And then 2 times 5 is 10. Right? And then the second number, 1 times 0 plus 3 times 5, 15. All right, good? Okay, now let's use the calculator. So what we're going to do is type this in as A, type this in as B. We're going to do A inverse B. So in the calculator, you're going to type in the 2x2 matrix as A, the 2x1 matrix as B, and then you're going to use the calculator to do A inverse B. You guys are good or no good? Good. All right. Last one, and then we are done. This one, just use the calculator. But I want you to try with inverse matrix, okay? So this matrix times the XYZ matrix is equal to the 20, 40, 30. Okay, use matrix to solve. Use your calculator to solve. Don't use RREF. I know you know how to do it. Let's try inverse matrix. 3x3, inverse, and then a 3x1.